Hey guys, welcome to day 45 of Codeforces Every Day Until GM. Let's just jump straight into it. Little Penguin and Polo has n times m ring. Okay, so yeah, I already started on this problem, but wasn't recording. So basically, we're given an XM matrix where the input is N, M, and D, and then the following lines is our matrix. And what we want to do is we want to print the minimum number of moves it takes for us to make all the numbers in the matrix the same. And how we can do that is we can add or subtract D from each element of this matrix. And if it's impossible, print -1. So basically what I have so far is I just taken the inputs, right? And so this question is 1400 rated, has a ton of different tags. So it's kind of throwing me off a little bit. But the first thing that we need to do is probably determine if this matrix is even possible to make all the numbers the same, right? So in order to do that, we should, for R and let me think. For R and matrix, for C and R, if C mod D equals the remainder equals matrix O mod D. Change this to D equals remainder does not equal remainder, print -1 exit. So what this does is checks if it's even possible or not, and so this should run. Now to get the minimum number of moves, I feel like it's some sort of like average or something, like you sum everything. So they say 4 moves because we can increase by 2, decrease by 2, increase by, or decrease by 4. Just get 4, 4, 4. So I'm trying to see, I need a whiteboard. So we have 2, 4, 6, 8. This is 20. Divide by 4 is 5. 20. The average of these is 5. But our D is 2, so how does this actually correlate? Well, 4 fours is 16. Twenty is 5 fours. 16. So I'm thinking of some like it's something plus remainder to find the number, because if we find the number that these should all be, so 4 in this case, then well, this should be a multiple of D. So what we should do is divide all these by D. We have 1, 2, 3, 4. Sum them. 10. Now what? 10 divided by 4 is 2.5. What do we do with this? Well, we can either choose to seal or floor it. If we seal it, we get 3. If we floor it, we get 2. Times 2. And then we... Okay, so now we just did a circle, so... I think it might be something like... We sum everything. Subtract by the remainder, divide by the number of elements is 5. So... But we can't make 5. So maybe we do have to do the loop-de-loop. Because we want to check basically... Okay, so... 1, 2, 3, 4. Sum it is 10. 10 divided by 4 equals 2.5. So we basically want to check 2 and 3. Times 2 is 4 and 6. So we want to do 6, 6. We want to do min. Okay, we have to sum. Okay, moves 2 equals 4 minus 2 divided by D is 1. 1 plus 0 plus 1. Okay, this has to be abs. Plus 8 minus 4 is 2 equals 4. This is 4. And then moves 3 is equal to 6 minus 2. 2. Wait, mod? It's supposed to be mod 4 minus 2 over 2 is 1. It is 4 over 2 is 2. So it's not mod, it's divide. It's 2 moves. Wait, what's going on? What is 2, 3, 4, 6? Oh, 6. So do 2, 4 minus 2 over 2 is 1. Wait, no, we do 6 minus 4 is 1. 6 minus 6, 0. 8 minus 6 is 1. So this is 1, 2, 3, 4. It's 4 either way. Huh. So it doesn't matter if we floor or seal, now that I'm thinking about it. Does it? Because it's always the average. Yeah, it doesn't matter. It shouldn't matter, at least. So what we should do is we should sum everything. Okay. We can have this here, and then we can have this is n squared. Can I do this without n squared? No, I have to iterate through each. Do this. So we'll have the sum of the matrix at the end, and then Sum minus remainder divided by n times m. Sum minus remainder divided by d. So I need to import math. Math dot floor. Actually, I don't even need math. I have double divide. Sum minus remainder sum. Okay. 2, 4, 6, 8. Sum is 20 minus the remainder divided by 4. Okay, divide by d is 10. Divide by 4 is 2. This isn't right. Two times d. And then moves equals 0. For row and matrix for column and row, we check it's abs d. It's okay. It's abs c minus a average divided by d. Moves plus equals print moves. Okay, that worked. Now this is n squared. Is this time complexity good enough for this. We do have an 100, so it can be 100 times 100. This is the bottleneck, right? Something's not. Hmm. I'm trying to think. Okay, there's this one case where it's. Okay, let's just say we have 1, 3, 1. We have like 1, 2, 100. What we do is we find the average by remainder is 0. We sum to 103, divide by 1, divide by 3, which is 34. Right, this is 102. Yeah, so 34. It's like 34.333 or something. So 34 times 3 is 102. So our average is 102, which means we'd add 101, 102. So that's not right. What we actually want is That's still not right. If we just pick 2, there's 1, 0, 98, so it's just 99. So if we do we pick 2, 0, 1, 100, 3, 1, 2, 97, which is also 100. So it's actually the median. We don't want the average. Median means middle. So, okay, this is interesting because now this means we don't need a matrix. We basically just need a very long array. So what we can do is wait, what does this do? Let me figure this out. Oh, okay, so what I do is matrix plus what's row? Yes. Now for in tricks, we can still have this, except it's no longer 2D array. And then if I mod d does not equal to remainder, print -1 exit, and then calculate moves equals 0. Well, we need to find the median. Wait, now I'm suspicious of this scenario. Median is 2. 1, 0, 0, 98. If we do like 1, 2, 3, 3, 100, median. Uh, 97. Now what if we do 1, 2, 2, 2, 3, 4, 5. Something like this. 1, 2, 3, 4, 1, 2, 3, 4. This is the middle. This is 2, 1, 1, 1, 1, 1, 1, 97. Oh, this is 1, 2, 3, 97. But if we chose like one of these twos, it'd be 1, 0, 0, 0, 1, 2, 3, 4. So okay, these make up for it. And then 98. So these should be 3 cancels out. These cancel. And this one's actually more. So okay, so this median, it should be the median. No, median. Okay, so to find the median, it's just len over 2, floor len over 2, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. Is 4, 0, 1, 2, 3, 4. Median equals len matrix over 2 and then we just do for in we can build this in here, right? Like we can also track moves. Moves plus equals median abs median minus matrix I, and then we just print moves. For I in matrix. Abs minus I, like this. This one worked. This one gave 12 for some reason. So we have 2, 4, 6, 8. Our median is... Oh, we're getting 5 as our median. So what we need to do is matrix len matrix divided by 2, which means we should get 4 divided by 2 is 2, so getting 8. Okay, so it should be, what's our median? Median is 6. Minus 2 is 4 divided by D. Okay, I think that's it. Now it's no longer n squared, it's just n. Wrong answer. Okay. 5, 7, 1, 2, 5, 100. So I need a sort, basically, actually. Undo matrix of sorts. There we go. Got it. Nice. That took about 40 minutes. Alright, moving on. Look at this. We are 1, 2, 3, 4, 5 questions away from finishing up this ladder. Oh, by the way, guys, I have took the time to reformat everything to the number values, so that's cool. That's what I spent my morning doing. As y'all can see, they're all in this format now, where it's name, link, rating. I'll like this now. Took a little bit of time, but it's worth it, because then now I can keep track of the different problems. 1300 problem. Just who has invented a kind of sequences? They meet the following property. You're given x and y. Please calculate the modulo fn modulo 10 to the 9 plus 7. Okay. Okay, what's our input? nm. And then second line contains a single integer. Or first line contains xy. Second line contains n equals n to input. And then output a single integer representing fn modulo 10 to the 9 plus 7. So what is fn? f1 is x, f2 is y. For all I is greater than, wait. So for all I, where I is greater than or equal to 2, f of I equals f of I minus 1 plus f of I plus 1. So 2 and 3. Calculate f of n. N is 3. So 2, 3, 3. We're looking for f I. Something like this, and then f of n. So we're looking for f of 3 is equal to f of 2, f of 4. So f of 2 is 3. Okay, let's take a look at this. In the first sample, f of 2 equals f of 1 plus f of 3. So 3 equals 2 plus f of 3 is 1. Okay. Second sample, f of 2 is negative 1. Negative 1 modulo this equals this. Okay, let's do mod equals this real quick. I feel like we just print could be 10. So it's like kind of recursive. We need to build our thing. F dot append x and y. This is f of 1, f of 2. To find the next number, we do. So to find f of 3, we would do f of 3 equals f of hold on, f of 2 equals f of 1 plus f of 3. So f of 3 equals f2 minus f1. f4 equals f3 minus f2. And then we basically want to call f of n minus 1. So print f of n minus 1 mod. Uh, okay, so we just need to iterate for I in range n f of I. Well, we start at 3. F of I equals f I minus 1 minus fi minus 2. Index out of range. So we're saying 3 f of 2 doesn't exist? 0 f of 1. Two, 3. So basically f dot append like this. N minus 3 plus 1. Why exactly isn't this working? Oh, is it 2? 0, 1, 2. 2, 3, 1. The f of 4 is f of 3 minus f of 2, so 1 minus 2, 3, -1. For now, f of n, 0, 1, 2, 3. So we're printing out -2. What the hell? Which is not good. Wait, we got it. Okay. Guess that works. Memory limit exceeded. Okay. So, here's what we can do about that. We don't actually need to track all of this. We only really need x and y, right? And track a to print. Set x equals or to print equals f of 2 minus f of 1. And then we set y equal to 2 print and x equal to, we set x equal to y and then y equals to 2 print. And then we just print 2 print. It's over. -2. Okay. So f of 1, f of 2, f of 3. F of 1 is equal to x, which is equal to 2. Y is equal to 3. F of 3 is equal to 2 minus f1 is equal to y minus 2, where x is equal to 3 minus 2 equals to 1. So instead of n plus 1, it's just n. So why is this one failing? if n equals 1, we do x, y. TLE. What the fuck is test 4? A memory exceed and now time limit exceed. Is there an impossible case? It's just 0. The expected output is 0. So, but what if this is 1? It's just 0? It's 2, 1. TLE. But it's O to the N. It needs to be faster than O to the N? Not exactly sure where to go from this. Like, this is just a brute force approach, right? We just sum each one. It's O to the N, though. Needs to be faster? So there's some sort of like math, some sort of repetition in this, right? Theoretically, it should. Oh, yeah. Okay. Let me think. This is okay. So it's. This reminds me of like. Shoot, I don't remember. Wait, it should just be okay. So F1, F2, F3 equals F4 is equals. It's just negative x. So I assume F5 is negative y, right? Because it's negative x minus y minus x. So it should be plus negative y. So F6 is equal to negative y minus x, or negative x. So it's x minus y, and then the f7 was x minus y minus plus y, so it was x again. So x moves back to here. So it's a loop, or it's a what do you call it? A pattern or a cycle or whatever. And it goes x, y, y minus x, negative y, x minus y, x. What was this called? It's like a series. I'm thinking geometric series. No, some sort of series that like repeats itself. It's kind of like the integral of like sine and cosine, stuff like that. I don't remember what it's called, but okay. So basically, we can make this more mathy, where it's just n is a number. N minus. No, it's n mod 6. N mod. N mod 6 relates to one of these. So 3 would be 1, 2. Or, no, this is 0, 1, 2, 4, 5. So it's. N is 2. Then we want y. So it's 2 mod 6 is 2 minus 1. So if it was 7, 7 mod 6 is 1 minus 1 is 0. If it was 6, 6 mod 6 is 0 minus 1 is negative 1. So we should really just do n minus 1 mod 6. So it's 7, and it's 0. If it's 6, then it's 5. If it's 2, then it's 1. Okay, yeah. I think this works. And then so we store this in an array. To print equals x, y, y minus x, negative x, negative y, x minus y. And then we just print to print n minus 1 mod 6, like this. Okay. Make sure we cover all the bases. What if we have negative numbers? This one, 106. Right, I think this is fine. Should cover all the bases. This is O of 1 now, because it's just math. Nice. Okay, this question was quite interesting. It reminds me of my pre-cal class in high school. Okay, we'll do one more problem today. Okay. Appleman and card game. So after we do this one, we save 3 more problems for next video, I guess. And we'll finish this up next time. 1300 rated. Only tag is greedy. Interesting. Okay, so in cards, each card has an uppercase letter written on it. Toastman must choose K cards from Appleman's cards. Appleman should give Toastman some coins depending on the chosen cards. Formally, for each Toastman's card, you should calculate how much Toastman's cards have the letter equal to. Okay. Wait, what are we doing? Must choose K cards from Appleman's cards. Then Appleman should give Toastman coins depending on chosen cards. Calculate how much Toastman's cards have the letter equal to the ith, then sum all these quantities. There's a max number of coins Toastman can get. In the first test example, he can choose 9 cards with letter D and 1 additional card of any. So for each D, he will get 9 coins. 1, 2, 3, 4, 5, 6, 7, 8. Wait, no, this is 6, 7, 8, 9. So 9 Ds. And then he gets 1. So 9 times 9, 81 plus 1. And then in this case, there's no dupes. We can choose 4, so we just get 4. Okay. This doesn't seem that difficult. Basically we just use a counter. For each Toastman's card you should calculate how many of Toastman's cards have the letter equal to that, then sum up all these quantities. So what I'm worried about is, say there were 11 Ds, and we choose 10 Ds. Is that 11 times 10? For a counter, for collections, or from import counter. Letters is counter input, and then we choose the largest numbers, and we take each Toastman's card. You should calculate how much Toastman's cards has the letter equal to the ith, and sum. Okay, so basically, while k does not equal 0, while k is greater than 0, Okay. The wonder if it auto sorts or it auto orders. So basically what I should do if okay. Now, what is max letters output? Z 9. Letters, what am I thinking of? Letters dot. No, letters dot. Values. So I want this, but I want to get the letter. Do I? Do I want to get the letter? I could. I could do letter stop values. We can do Here we go. Okay. Now we do for count in counts if count greater than k. Coins plus equals k times count break, else coins plus equals k times count k minus equals count. Print coin. Something's not right. Nine four two, so it should be 9 times 9. Oh, you get, so you don't get per count, you get per take. So you want to greedily take the most anyway. Okay. So what we want to do, if count is greater than k, coins plus equals k coins plus equals count times count. Wait, k times k in this case is 10. So we had 11. Okay, wait. Say we had 11. So count is greater than k. So coins plus equals k times k. Break. Else coins plus equals is or equal to k. Else coins plus equal to k times count. So we have 3 and there's 2. We do 3 times 2, which is 6. If there's k is 1, and there's 4. No, we'll just do k times k still. No? 9. No, so we go here. Coins plus equals count times count. Okay. Now we need a case where just take this and then add 2Ds. Make this 17. 100. To verify, we have 11Ds, so we take 10 times 10 is 100. That seems like it should be right. So now I just remove this print statement here. Is there any other cases that we had to think about? If there's no, there should be it, right? Uh, from counter. It's all the same letter. About like 6, 3, eh, eh, eh. Then we should take 3 and be 9, right? That works. Okay, this should work. Come on. There we go. Would you look at that? 3 more. 3 more questions. That question took me maybe another 40 minutes, 45 minutes. Okay, these 1300 questions, we're getting faster at them. 1300 used to take me like an hour. Now it's only taking me 45. That's improvement. I like that. Or, wait. Did it? Because I remember we did a question and we finished at 38, but we did 3 questions. 1400. I don't know. We basically did 3 questions in an hour 31, right? That's not bad. That's 30 minutes per question. So yeah, low key, this is improvement. This is pretty good improvement, in fact. If I can do 1300s in like 30-40 minutes, that's pretty goddamn good. Um, but yeah, alright. If y'all enjoyed this video, make sure to like and subscribe. I'll see y'all guys tomorrow. Bye.